Chapter 8, Periodic Properties of the Elements. Dmitri Mendeleev lived back in the 1800s, died in 1907. He is often given credit for being the father of the modern periodic table. He looked at the elements that had been discovered at that time, and he was trying to find a way to put them together and make some sense out of them. And one of the things he looked at is he put them in order by atomic mass, and he saw that there was a repeating pattern of properties, a little bit like repeating notes on the piano keyboard. I have a picture of that coming up? No, I don't. So if you go up the piano keyboard, there's middle C, and then you go up 8 more keys, and there's another C, and then there's another C. And we see a pattern of repeating properties among the elements. And so what we call Mendeleev's periodic law is that when elements are arranged in order of increasing atomic mass, certain properties recur periodically. And that's where the word periodic in the periodic table came from. So he used those patterns to predict the properties of undiscovered elements, which was pretty neat. We had not yet discovered all of the naturally occurring elements. There were some gaps in his table, and he predicted what would fit in there. There were a couple of places where the atomic mass order did not fit with the other properties. And so he went with the properties over atomic mass. So if we look at tellurium and iodine in the periodic table, tellurium has an atomic mass of 127.6, and iodine, which is higher on the periodic table, is 126.9. So an atom of iodine weighs less than an atom of tellurium. Mendeleev ordered them in the same way that we have them on the modern periodic table because the properties of iodine line up with the other properties in that column. So these are two of the elements that he predicted would be discovered. What he called eka aluminum, meaning the element below aluminum, is now known as gallium. Here are his predictions for atomic mass, melting point, density, formula of the oxide, formula of the chloride. And he was spot on. So he said the atomic mass will be about 68. Well, 69.72, pretty close. Low melting point, 29.8. Gallium will melt in your hand. It's very fun stuff. Unfortunately, it's somewhat toxic too. I know, right? All the fun elements are toxic. Density, 5.9. Nailed it. And these. He also predicted that germanium would be discovered. He called it ecosilicon, and his predictions here too, very, very close. It's pretty impressive. Yeah?
How does like the borosilicate glass not react with any chemicals when we put it in like a beaker or a lemon flask? Is it just super inert?
How does borosilicate glass not interact with other compounds when you make glass out of it? I can't really answer that question. Okay. It doesn't, it's kind of off topic.
Yeah.
Do you have an on-topic question?
How toxic is gallium?
How toxic is gallium? I don't know off the top of my head. I don't know. And you know, toxicity is very relative, right?
We can use rubber gloves.
Yeah, I don't know if we have any in the stock room. I don't know. I know that would be really fun. Individual students cannot generally order elements online. You have to be able to prove that you work for an appropriate sort of place. Yeah. Yeah, pizza factory. They have a need for gallium. Okay, back, come back. Okay, so the what versus the why. Periodic law predicts what's going to happen, right? Periodic law allows us to predict what the properties of the different elements are. Doesn't explain why that is. Quantum mechanics is the theory that explains why this pattern is there. And when we know why, we can predict different whats.